All right, we are live. Hello, everyone. Manny here. I am your host, and today we have a very special guest. We have Erik Udstuen, who is the CEO of TwinThread. He's come on the show today to talk to us about everything digital twin, AI, machine learning, analytics for manufacturing, and other Industry 4.0 applications and industries. So we're really excited to have him on the show. We are live, so the nice thing about that is that you get to ask questions, you get to participate, you get to put your comments. So make sure that you're doing that in the chat, and we'll monitor that. We'll monitor that from time to time. But let me introduce our very special guest today. I have Erik here. As I mentioned, he is the CEO and co-founder of TwinThread, former founder of Mountain Systems that was acquired by GE. He After that he headed up GE Intelligent Platforms. That's now GE Digital. So, and I think he also acquired Smart Signals. But you'll have to give us a little bit more clarity on that, Erik. So, with that, let's welcome Erik to the show. Hi, Erik. Can you say hi to everyone and talk to us a little bit about TwinThread? What's your current role there?
Sure, absolutely. Yeah, thanks for having me on. This is looking forward to this. In terms of TwinThread and my background, I've spent 25 of the last 30 years doing industrial software startups mostly. I did spend 5 years, as you mentioned, running the industrial software business at GE, and we've just over the last 30 years been evolving really what analytics and digital twins kind of mean. And in this kind of latest venture, TwinThread, we're really taking digital twins to new heights by adding on a lot of analytic monitoring and machine learning capabilities to really bring this concept of predictive operations to reality.
Indeed. Can you give us a general definition of digital twin? How do you define that at TwinThread?
Yeah, that's a good question. I think everyone has their own flavor of it, own version of what digital twin is. And so we like to think of digital twins in 7 layers. And I won't cover all these in detail, but I'll sort of walk through our vision of what really digital twin means. First is a visual. It's probably the most well understood layer, if you will, easiest to wrap your mind around, visualizing a piece of equipment or a process. And that's the first layer. Second layer is the history, the sensor history in particular, really not just what the current value of a current sensor is on a piece of equipment, but also all the history. So then the third layer is the state history, or you might think of it like the events that have impacted that digital twin over the course of time. That's the third layer. The fourth layer is really some would call it first principle models. This is what we would call monitoring, really using sometimes simple, sometimes complex logic to look after a digital twin and to glean some insight from that. The next layer is learning models, models that aren't first principle models. Rather, they're models that are examining that history, examining the state as well as the sensor history to be able to forecast something, predict something in the future, or otherwise optimize a set of decisions around that digital twin. And then the sixth and seventh layer are the actions and alerts that are driven off of the digital twin. And the seventh layer, the final layer, probably the most important layer to think about when scaling digital twins, is what we call classes. Classes are really the interrelationships between separate pieces of equipment that may be similar. And classes and those connections between different digital twins are really how you scale, how you leverage the relationships between similar pieces of equipment or similar processes. And so that's a pretty complete stack of what a digital twin is, and different solutions may implement different layers of that stack and have different focuses. And obviously, just to kind of circle back to the beginning, the most well understood and often most talked about area is the visualization layer, where naturally that's the visual part. That's the part that humans can wrap their mind around easiest. But actually, there's a lot more value to be had than just visualization. It's really all about the monitoring, the modeling, and then ultimately driving actions around those digital twins, where you get the exponential value from the concept of a digital twin.
That's a really good overview. 7 layers, a lot to jump into.
Yeah.
My background is in AI, machine learning, analytics, and I found that when I was going into some of these manufacturers trying to pitch them on AI and machine learning, that there was always like a lot more work that needed to be done up front before we could really get to the value of AI and machine learning. And I feel like that's step number 5 or layer number 5
That's right.
in your
That's right.
hierarchy. And I totally appreciate that, because then I would have to go up step number 1 and just to start with a simple visualization and say, hey, like, let's just grab an image of your object and let's tag where the data is coming in. Let's document the data streams that you have right now. Let's do some basic monitoring and let's start there. And I always felt like I was coming in and trying to get going with AI and machine learning, but I was always having to go back to square one. So it makes sense that hierarchy that you've laid out. Have you seen that?
Yeah, absolutely. Yeah, that is, you described the journey. Really, it's build the foundation, build the context as part of the digital twin. That's both the history and the state information, and then use that history and state information to power models. And it's AI is, I think, a lot of people have this perception that is this magic bullet that solves all the world's problems, but it's still like any other technology. It's garbage in, garbage out, right? So there has to be a lot of care taken in building up the data infrastructure and context to properly feed the modeling layer and properly contextualize that data for modeling.
Erik, what's the best way to make that pitch? Because I've been in a situation where I'm trying to show the value of AI, and in order, or in your case, analytics, digital twin technology, and in order to do that, we need to do some upfront data infrastructure work and data pipelining. But then, what's the justification for that? Well, it's the AI that's going to come after the case, so it's kind of a chicken and egg kind of thing. Have you found a great way to get manufacturers and industrial players to appreciate how much work needs to happen up front before you get to the great stuff of analytics, predictions, and machine learning?
Yeah, I mean, we communicate this as a journey, as I mentioned, and as you highlighted, and that today's technology, as opposed to technology of even 5 or certainly 10 years ago, you can move through these first steps of the journey very, very, very quickly. I mean, we talk about with our platform moving through those first steps of the journey in minutes and hours, as opposed to what even 5 years ago was much, much longer than that. So it's not so hard when you paint this journey and you get a clear understanding of what the journey is with the customer. If it only takes a few hours or a few days versus months or years to move through the first part of the journey. So that's definitely part of it. The other part of it is that even though you may want to jump directly to the modeling and the AI piece, You do not want to skip past the 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 first steps of that journey, because and we call this in our implementation process baselining. Like if you're doing your first AI project, of course you want it to be successful, and of course you want to be able to paint a picture for leadership. This was the benefit, but how do you do that without establishing the baseline and establishing where you're currently operating today? I mean, I can't tell you how many times we've worked with a customer and we baseline where they're operating today, and where they're operating today is a complete surprise. Sometimes it's better, and therefore it says, well, maybe this isn't the best use case to start with because you're like operating better than you thought you were. But a lot of times it's considerably worse. You know, they believe that their efficiency or their waste was X, and in fact it was, you know, not that. And that sets up, you know, the momentum to not only you're establishing like that foundation of good data, you're also setting up the momentum to go through the more difficult parts of the journey, which are the modeling and the AI parts of the journey.
That is spot on. And I really like that as well in terms of baselining and figuring out where you're starting off and building on top of that. I think it's also pretty important when you get around to AI and machine learning from the perspective that oftentimes you want to start with a simple model, and so you want to see what kind of lift you might get with the simple model. So if it's just
Mhm.
rules based and you get a little bit of a lift, okay, that's okay. And then if you want to try something a little bit more complicated, maybe regression, then maybe to a neural net model. Every time you do that, you want to make sure that you're getting paid for that. You're getting some lift in terms of your effectiveness. And if you haven't done that initial baselining, then you don't know what gain you're getting by that additional complexity. So from that perspective also, it's going to help you quite a bit, and it's going to help your data scientists, because instead of your data scientists going around and trying to put together the most complicated model, maybe they just put together a straightforward model, and it yields a lot of benefit.
Yeah.
And it's easier for them, it's easier for the company, and you're kind of you're rolling with that.
Right. Yep. No, you got it. You got it.
You mentioned in your earlier comments around classes and being an ability to scale digital twin. I think that's sort of a really great selling point of a TwinThread. Can you talk a little bit more about how you're doing that, how you're leveraging classes to scale,
Yeah.
not just to one machine, but I'm assuming to hundreds of machines for a
Yeah.
company?
Yeah. Let me use a real use case here to kind of bring it to life. One of our largest customers monitors critical power equipment in data centers. So it's not a manufacturing application, but I think you can sort of translate this easily into a manufacturing context. So in this case, they're monitoring over 400,000 critical assets and have digital twins on over 400,000 assets. And on top of those 400,000 assets, which are of various different types, there's a set of monitoring logic, a set of alerts, a set of models. And kind of to give you a sense of scale here, we're talking about 20 million sensors, 12 million what you might call first principle models, 750,000 predictive models. Really, you could imagine if you were doing those things one at a time, it would take you years and years and years to implement and train and to like deploy 750,000 models. But through the concept of classes and really the connections and the similarities between equipment, we can do that in bulk, in essence, and still train models to the specifics of an individual equipment type or individual asset type, but do that in a very automated and scalable way. And that's truly the only way that you would scale an application like that, is through the concept of classes.
Very neat. And do you have a library of those classes within TwinThread that you're tapping into? So based on your clients, their use cases, and
Yeah.
what you've seen, you can automatically deploy that to a new similar type of customer.
Yeah, so I've got a couple things to share around that concept, because that's a very common question, and a very sort of popular concept. And what I'm about to describe, I think, is somewhat countercurrent in the market. Um, our belief is that the classes and the knowledge and the models and learning that are developed from those classes is the intellectual property of our customers. We are specifically not building a quote unquote industry database that is consolidating multiple customers' information and monetizing multiple customers' information. We are providing a platform for an individual customer to build up their own intellectual property set and own that. And we make that very, very efficient to build and manage. And, we think that's an important element for a customer to actually own that IP that gets produced from the platform. Um,
Yep. Sorry, go ahead. Go ahead. I'm sorry to interrupt.
Yeah, the anecdote I would give you is that, just kind of sharing an experience from my days at GE, where we were doing massively scaled monitoring of power equipment, specifically gas turbines, like 50% of the world's gas turbines, essentially. And there aren't that many different types of gas turbines. There's about, let's say, 6 major types of gas turbines. And so one would think that having data on 50% of the world's gas turbines, and there's only 6 types of them, that you could build up this huge industry database that just perfectly described, perfectly modeled how those pieces of equipment behaved. The reality is that each piece of equipment, each power plant, each turbine needed to have its own personalized model. And so exiting my experience at GE, I felt like what we needed, in the industry, was a tool to very quickly build personalized models down to the individual equipment level, and then have the resulting models be the property of the customer rather than the vendor of the software. And that's quite countercurrent to what others are doing in this space.
That's great, and that is somewhat counterintuitive. You would assume that if you have a wind turbine somewhere, that you could just take a standard model and apply it to another wind turbine elsewhere. But I think you're right. It's hard. You have to personalize it a lot more than you would like. And why is that? Is that just because
Yeah,
of the context? Is it because you have a gas turbine that's
yeah,
working like in an area that's very high performance, and maybe it's like hot and humid, but then you have another gas turbine that's kind of hasn't worked that hard for a while, and it's in a colder,
yeah.
drier environment? Is that the reason why that's the case?
Well, let me answer by, let's separate first principle models, like physics-based models, from machine learning models. For sure, the first principle based models are going to work across a fleet of a certain type of equipment. For sure, the actual manufacturers of that equipment are going to be in the best position to create the first principle type models for that. And it's another reason why we believe that intellectual property should be owned by the customer. In that case, the customer being the actual equipment manufacturer. Like, the equipment manufacturer should own their own first principle models. However, from a machine learning modeling perspective, which now we're trying to really suss out the very subtle behaviors that are happening on an individual piece of equipment. And to use the gas turbine analogy, it's about the fuel type, the fuel quality, It's how it's connected in with the grid. It's the auxiliary equipment around the turbine. There's many factors, the climate, that impact the subtleties. So it's like the macro performance characteristics can be captured with the first principle modeling, but the micro, where the rubber meets the road and the difference makers end up being very personalized down to individual piece of equipment.
Do you have a sense, proportion wise, in terms of the value of the analytics? Where is it coming from today? Is it coming from the first principles based modeling or the machine learning based modeling? If you can quantify it, or what's your kind of gut feeling about that?
Yeah, I'm yeah, it's well, let me put it this way, and just to be very, very sort of transparent and balanced about it.
Sure.
Let's not think of it in terms of value. Let's sort of think of it in terms of a ratio of value to effort.
Oh, okay.
And for sure, high value to effort in kind of building out the visualization. If we go back to layer 1 of the digital twin, high value per effort for that. Let's give that on a scale of 1 to 5. Let's give that let's make that the 5. Value to effort. Definitely, the next in line is the first principle modeling, and let's give that a 3 out of 5 for sort of value per effort.
So you're gonna start to interrupt, but you're gonna get a lot of value for a small amount of effort for the visualization, also for first principles modeling.
Yep. And then if first principle modeling is a 3 out of 5, then probably AI modeling is a 2 out of 5. Takes a lot more effort. I think if you're going to get a tremendous amount of value out of it, but it does take effort to get there, and it takes a lot of data. So that's sort of factored into that, value per effort. So it's a commitment to go get that value. But that's how I would sort of describe it to customers.
But I really like that, because in your framework, you've accumulated some value up until that point, so that you can afford to wait for that data to come in, so that you can learn, so you can train your machine learning based models.
Absolutely, yeah.
Right, because sometimes, like, you come in and you do the investment, and your customer's like, okay, I'm ready for my insights, and I have to say, well, you have to wait a year to collect all the data, so that we can train the model and give you the insights. But because of the visualization has been done first, because of the sensor history, because of the first principles based modeling, you've kind of accrued some value to draw down as you're waiting for the machine learning to come in and add some more value.
Right. And I, in my ratios there, I'm also factoring in, the change management. If you think about it, we go through those layers, that journey of implementing a digital twin. It's not really until we get to the modeling piece where there's really any significant organizational change management. In other words, up to that point, we're just putting analytics in front of a human sort of interprets them, or we're creating alerts automatically and a human interprets the alerts. It's not really till we get to the machine learning and the autonomous operation piece that it starts to make a difference. And just to use another anecdote, one of our customers is Colgate, specifically within their Hills Pet Nutrition division. They just did a talk at a conference about what they were doing with our digital twin, and that is really implemented all the layers that we talked about. They've really gone through the full journey, and they have achieved like autonomous operation, where we're using models coming from the digital twin to not only recommend changes real time for an operator to make, but integrating that in with the control system and having a fully closed loop system. Now you can imagine this from a change management standpoint, and achieving that result, which is extraordinarily valuable, has some cost to it in terms of change management. We're asking operators that were typically turning the dials to step back and take their hands off the wheel and let the models make the decisions on how to control quality in this case. Very, very, very powerful, but is a significant commitment from the operations team to adopt technology like that.
And using your framework, because you've already shown value, would you say that it's easier for those change agents within the organization to make the case to their technology teams, to their operations teams?
I'm sorry, could you repeat that?
Yeah, sure. So, because the teams have already built up some value and are able to show it and can
Yeah.
demonstrate the technology and point to some use cases where they've actually used some of the insights, and now they're getting to the point where they have to do change management. Well, they can use that to make the
Yes.
case to
Yes,
those
absolutely.
teams.
Yeah, I mean, not to sort of put a negative spin on it. I mean, you can literally say that this is what a model would have done. This is what an operator did. Like, you can compare the model would have been a better decision than what an operator made. And maybe that's not, if presented improperly, maybe that sounds scary or bad for an operator. It's actually good because, when mistakes are made, it not only costs money, it takes operators time, to deal with bad product or to do things. So it's, I think there's a quality of life thing there. But I mean, in terms of justifying, that is really the tactic. This is what the machine would have done. This is what the human would have done. On average, the machine makes better decisions if this is all sort of configured and built properly.
Eric, can you talk a little bit more about speed to deployment? Because having been in this space for some time now, I've 5 years now in the industry 4.0 AI kind of space. Um, you know, I think when I started, it was all right to not necessarily show software that can be turned on in hours and weeks, but I think that's more and more becoming the standard. So you just can't come in and talk about analytics and machine learning. If you're a vendor, if you're a software vendor,
Yeah,
you have to demonstrate working product code and solutions.
yeah,
And if not, I mean, hours is a little aggressive, but weeks for sure. Like you're no longer going to get the 6-month POC to show what you can do.
yeah. I think that's absolutely right, and customers are driving that. Um, I suppose it's true of any kind of a technology adoption cycle that this is inevitable. Like the customer's expectations start to shorten over time. Um, so um, yeah, I'm sorry, I lost my train of thought there.
No worries. What does that look like for a customer at TwinThread? How does that process work in terms of turning on the software? Because I really like your pitch. I go onto your
Yeah,
website and your pitch is essentially like just try it. Just try it for turn
yep.
it on and see how it looks to you for a week, and you can do that like very quickly.
Yeah, now I actually remember what I was going to mention. In the early days of AI machine learning, it was sort of okay to start with data in a data lake and then kind of use it in a tool that was going to do some modeling and really experiment. It really started to break down when customers expect, okay, great, you did an experiment, you came up with a model, it looks very interesting. How do I actually operationalize it? How do I take it and start actually using it in the process? And that's where the expectations really started to shift. It's like in the early days of experimentation, there was enough value proven and sort of offline. So as we view it, the problem isn't starting with the data lake. It's actually starting out at the sensor and having a very repeatable path of data that gets collected, prepared, filtered, contextualized, and ready for modeling. And that's the piece when we talk about, minutes to hours, that's the piece that we talk about, making very, very, very quick. So, our journey with customers starts with, what control systems do you have? What on-premise data systems do you have? And do we have an out-of-the-box connector that allows you to, in a minute, connect to that data source and start bringing in that data? That's the starting point. And then the next step is building out the digital twins. We build out the digital representation of the equipment. And I would point out the processes. That's something I didn't comment on earlier that's kind of missed in digital twins. We're not just building digital twins of the equipment. We're building a digital twin of the equipment and the processes that connect them. So that's sort of like the second step. And through that, you're building the context and the data contextualization that's needed for modeling. And so we want to get through that first step where we can start training our first model very, very, very quickly. Now, in the modeling step, we have a very important sub-element that we call evaluate. What we literally want to avoid is, or at least we want to have fast failure around, is trying to optimize something that isn't optimizable. And so in our modeling step, we have a sub-step called evaluate. And the whole goal of that step is to look at the data, understand for the given use case, what is the potential for improvement? And also, do you have the inputs, the data that explain enough of the variation in the thing we're trying to improve to justify continuing the modeling process? So we not only do we want to get very quickly up to the point where we have contextualized data, we also want to get to the point quickly to make a decision on, is this worth proceeding? Is there enough value here? And is there enough explainable variation in what we're trying to optimize? That meaning, do you have the right data to support the use case? We want to get to that. And if the answer is no, we want to stop and not waste time. And if the answer is yes, then we want to continue. And then, move forward with some of those more expensive, more complicated bits that we talked about earlier.
Erik, during this onboarding process, how much of it is just self-service versus tapping TwinThread's expertise, either forward deployed engineers or pre-sales engineers, to help with some of the setup and integration? Because I would imagine there are going to be some cases where you are going to want some help from TwinThread to set up some of those initial builds for the software.
Yeah, I mean, a customer can do anything in our solution themselves. And of course, we can do everything for them. But I mean, the most popular deployment model is what we call assisted onboarding. And we assign an onboarding consultant. And that onboarding consultant isn't someone who just trains you how to click through things. That onboarding consultant typically has an engineering background. Maybe it's chemical engineering or industrial engineering or control systems engineering. Typically has process experience, quality experience, things of that nature. So this is more than your typical, software onboarding consultant. They're there to really help you frame up the problem you're trying to solve, help you evaluate, as I mentioned, whether this is something worth solving or not, and then guide you through the process of operationalization. Like, how are you going to take the results of a model and actually use it in your production process, or use it in your, in your with your equipment.
Does it matter whether that onboarding consultant, or excuse me, the I think onboarding consultant, does it
Yep.
matter whether or not they're on-prem or remote? Has that changed how you're doing some of these onboardings?
I think that as we're exiting the pandemic, there's nothing that no substitute for working face to face, at least a little bit. But honestly, we do 95% of our work remotely, and even pre-pandemic, and it is just a very efficient, both for us and our customers, to not travel. I mean, let's be honest. That takes a lot of efficiency out of and as long as we're effective, it it's a better way. Working remote is a better way. But having said that, there is no substitute for getting face to face and breaking bread, as some of our folks say, with customers. But we can be very efficient remotely.
Erik, can you talk a little bit about how the industry has changed since you've mentioned you've been in the space for, I think you said 25 years, or yes, 25 years. So I'm sure you've seen like just
Yeah.
a ton of evolution. As you look back on the career, what's so unique about this time that we are in right now that we should appreciate, especially those of us that are just coming into the space on our own?
Yeah. So this will age me a bit, but I implemented my first machine learning model, a neural network model, on a paper machine to predict sheet breaks on a paper machine back in 1990. It was very successful. Like, in terms of accuracy, we were able to predict breaks on a paper machine. And for anybody who's in the paper industry, this is literally the holy grail of modeling, if you will, in that industry. And so that was 1990. So it's something that we made successful, and we've spent maybe a couple $100,000 at the time on the software, and it would take a full-time engineer to keep it up to speed. And so at that time, I took on a new job, took on a new responsibility, and guess what happened to that very accurate, very powerful model? It just died. So, I fast forward to today and think, we can actually do in a sustainable way today what, 30 years ago was very, very expensive and unsustainable, and so that's driven a lot by the power of what's available in the cloud. I mean, the power of what's available as open source in terms of algorithms, and how you can take them and pull them into a platform that can operationalize those algorithms. And the scale of the cloud also just makes a huge difference. So we can take the same effort that it would have taken to look after a single system on a single production line, and we can do that for thousands of plants, thousands of production lines, hundreds of thousands of pieces of equipment, and we can just do that much, much more efficiently.
That is spot on. As I talk to my customers about AI and machine learning, I kind of have to explain that the buzz around AI and machine learning isn't necessarily the algorithms itself. It's just the context and the tooling that's available now to make it happen. We've had neural net models for 20, 30 years, but
Yep.
we didn't have AWS and Microsoft Azure to store a whole bunch of data. We couldn't get the data coming off of the machines because we didn't have the right connectivity. We didn't have the gateways. We didn't have access to cloud-based notebooks, so like I can now spin up an RStudio notebook or a Jupyter notebook and write a
Yep.
model from anywhere in the world. I have access to GPUs, TPUs. Like that was not around. So you have
Right.
the tooling, the infrastructure, and I think the cultural appreciation as well for analytics and data now in a pre-Moneyball type of world that
Yeah.
that is making it all come together. And now that's part of the reason why AI is in machine learning is seeing a renaissance of sorts.
Yeah. I absolutely agree. And it's not like the desire, 25 or 30 years ago wasn't there to see around corners and to predict the future and to like generally be more proactive. It just, the desire was there. The desire has been there all along. But it isn't until, I'm going to say, the last 10 years, but I mean, in a practical sense, maybe even the last 5 years, where it has become feasible to be proactive at scale. Um, many companies have had success deploying an AI solution on a single line for a single use case. And even going back maybe 15 years, they may have had some sort of pilot success or limited success. It hasn't been until recently where we can even talk about this customer has deployed 750,000 predictive models and was using it every single day, and here are the results of that. Like, those stories are only coming into reality in the last couple of years.
Right, and now that's the bar. Now, to your point, it used to be that you could just show a simple use case, a model, and for one line, but we're past that. You have to be able to show that, and you have to show how you would deploy to thousands of machines if you got the green light from the company to do it.
That's right. Yep.
Um, can you talk a little bit about what technology folks get wrong when trying to deploy some of this technology into the manufacturing space? So I feel like
Yeah.
there's oftentimes a disconnect. I was at a company where we had Silicon Valley tech people, and we were hopping onto the factory floor, and sometimes I felt like we weren't striking the right chord, and there was some getting along that had to happen at first. So, in your view, is there an approach that a technologist needs to be taken as you're trying to deploy into Industry 4.0?
Yeah. I'm chuckling a little bit because we've over the years we've gone through sort of multiple waves of different sort of organizational tensions, related to technology. It started with networking, and were the corporate networks going to be able to connect to the control system networks, and there's a big battle over that. And then, uh, there's been a battle between sort of uh, OT and IT, let's say, who's going to control the data and who's going to work with the data. And I think the latest battle uh, is a nuanced version of the IT versus OT sort of organizational tension, and it's the engineer versus the data scientist. And I hate to like present it like it's a adversarial thing, because it's not. But there is organizational tension between those roles on who is best equipped to deliver these new technologies like AI, machine learning, uh, into an industrial organization. Maybe if it's an insurance company, maybe not so much of a debate. But if you make stuff, whether you make equipment or whether you're a manufacturer that makes stuff, there's real tension there between the engineer and the data scientist. And the fundamental question of, is it easier to teach the engineer about data science because they understand the process and how all the process works? Or is it easier to teach the data scientist about the process so that you can achieve? And I'm not going to answer that question. I mean, I have opinions. I just think as a software vendor, it's our job to bring those roles together around a common platform and make it easy for the data scientists to do their value-added work, but at the same time, make it so the process engineer, the engineer can succeed as well, because it's a fit for purpose digital twin platform that's role in life is to optimize the process. So we have to build it in a way that the engineers that work are the subject matter experts in that process can succeed. So kind of very indirect way of answering your question, but as I see it, that is the 2020, battle of organizations, is who gets to do the data science. And, from our perspective, everybody should get to do the data science. And we need to create tools that help all of the roles in an organization succeed. And we just happen to be focused in on the subject matter experts, the process engineers, the chemical engineers, and so forth.
I think that's the right place to be at. I'm a big fan of upskilling engineers with data science capabilities. So get a quality control engineer and teach them some Python or some R. That's usually your best route for a couple of reasons. One is, there is, to your point, it's engineering versus data science. And engineering, there's a lot of nuance that isn't captured in the data. So as a data scientist, I would look at the data, I could figure something out, and
Yeah.
then I take it to an engineer, and they're like, no, you've obviously missed this key part of the process. Well, I didn't see that because I didn't see the data, but you would know it if you were on the factory floor, if you had been involved in the process. There's like a lot of these big gaps that you have in the data. And so I like it from that perspective. I also
Yes,
like
that,
it.
that illustrates why there needs to be something where they're working together, and something that worked with a Jupyter notebook, but also works with an Excel spreadsheet, so
Right,
um,
or no code options. I think you're
right,
working on no code, low code. That's great. That's great as well, because that's going to help some of these engineers, get involved in if they want to get more into the code. Fine, but that's not stopping them to
right.
just start getting involved.
So you asked, like, are they getting it wrong? Um, some, and to tie it back to sort of the waves of technology, in the old days, if someone said the word network, well, that meant that this sort of IT group that worked on the networking had to be, involved for sure, but made the decision. And so today, if the word machine learning comes up, it immediately goes to the data science team. And that data science team might be working on, Salesforce analytics, or, product mix analysis, or demand forecasting, doing super, super valuable things, but not necessarily focused on solving problems out on the plant floor and giving operators better tools and better recommendations on how to run better. And so, that's more of how they get it wrong, is when you try to force fit, just because of the technology moniker, like you try to force fit it into this part of the organization, when really it should be thought of maybe a little bit higher level than that.
That's a great point. That's a common mistake that I see as well. You have leaders that just see data science, that can do data science across all domains, but data science will vary from domain to domain, and technology to technology, and even use case to use case, from natural language processing to image recognition to predictive analytics. These are all highly fragmented, and just because one team can do one of those well, to your point, demand forecasting, doesn't mean you can quickly turn around that team and have them do predictive analytics on a machine on the ground floor. There is a lot that has to happen for them to be able to do that well.
Right.
Can you talk a little bit about the companies that are doing digital transformation right? I'm sure you're seeing a lot of folks come through. Some of them are having great success with your technology. Others are not having maybe the best results, and it's the same technology, same experience. I'm guessing that there is a difference between what some of the better companies are doing when it comes to digital transformation versus the ones that are having the best experience. Have you seen that? Can you talk a little bit about that?
Yeah, sure. I'm not going to single out anybody specifically, but certainly uh, it's really the speed. I wouldn't. It's not so binary as success or failure, right? It's really speed through the journey. And just like in any other technology, you have the early adopters and you have the early majority and the late majority, and certainly those that are true early adopters understand that it is a journey and kind of commit to the innovation. And those that are maybe slower are more expecting a point solution, or they're thinking about it at a single use case level as opposed to a platform level of something that's going to solve a whole variety of problems for them. And so, things tend to go slower if a company is just focused on a singular use case. Things tend to go slower if that singular use case is a science experiment and not a true operational problem with big dollars associated with it. And so, the companies that kind of frame up the problem in big economics and frame up the problem from a platform and capability perspective end up, ironically, even though that sounds big and intergalactic, ironically going a lot faster, because working on big problems helps to get big organizations, the momentum they need to power through the steps of the journey and do that, relatively quickly. Companies that are kind of thinking of I'm going to dip my toe in the water, I'm going to try it on this small problem that doesn't really matter if it succeeds or fails, but we'll learn something from the experience, that we engage in those projects, but those go slower because even if you succeed, it's you succeed, you prove that you have this really accurate modeling, for example, but you solved a non-important problem. It's it's just a shrug of the shoulders and okay, what else? What are we going to do next? We still engage in those projects, but absolutely go much, much slower.
What are some of the driving factors for those companies that are making the play towards a big platform play? So they have some conviction, they know that they have to start moving in a more digitally transformed way. What are some of the factors that are driving them to make those big bets? Because I would imagine that you need some really big reasons for making that big investment.
Yeah, I mean, sustainability is a hot topic, and it's in a lot of ways, I think companies know they need to address sustainability. They know they need to put points on the board, but honestly, it maybe they aren't as disciplined as actually measuring the benefits of that. So sometimes it's a big initiative comes out of sustainability. Sometimes a big initiative comes out of a recall problem or a quality problem, and sometimes a big initiative comes from demonstrated success, in one plant, expanding to another, and there's leadership that can recognize that success and what it could mean at scale. Sometimes it's sort of more of a bottom up, but obviously we like to see as a vendor, we like to see the big initiatives, the big edicts, that come down from the CEO that says we're going to be more sustainable, or we are going to be a leader in quality, or we are going to be, fill in the blank. That certainly gives you a lot of momentum to do do the big things.
Erik, how would you like the industry to change in the next 5 years? You've been in the space for 25 years. What's like the best case scenario in 5 years for analytics, for manufacturing,
Yeah.
for AI, for Industry 4.0?
I mean, our vision, and it's just now starting to become a reality, is autonomous operation, and taking the use case that I described earlier about like automatically controlling quality based off of the digital twin is an example of that. And in our vision, that companies will be able to optimize dozens of factories from a single virtual control room. That's not mean you're going to replace all the individual control rooms in a plant, but rather you have this central virtual center of excellence that's able to push out recommendations to dozens and dozens of plants, and just to do that very efficiently. We see pockets of that in certain industries, like power generation, for example. It's been the concept of having a centralized control room, like that's working over the top of many plants and feeding information back to the individual plants, sometimes real time, on how they can actually run better, run more efficiently. I think over the next 5 years, we're going to see that same concept working its way into consumer products, food and beverage, especially chemicals, a whole bunch of other industries that traditionally ran plant by plant by plant. And especially for those companies with scale, there's a tremendous opportunity to do work to optimize from the central virtual center of excellence that allows you to get a lot more efficiency out of the whole network of plants, as opposed to individual plant or an individual line. That's where we'd like to see things go, and I think it's certainly a possibility.
Great, Erik. It's been a great talking to you. We're at the end of our time here. Any last comments that you want to share with the audience? Where can people find you? How do people get in touch with you?
Yeah, absolutely. Come to our website, TwinThread.com, and check out what we're doing. There's many ways to engage there, from videos to content, and we're trying to improve that all the time. And of course, feel free to reach out to me directly and to engage on this topic. Obviously, we're very passionate about it, and appreciate the opportunity to come on today and talk.
Great. All right. Well, thank you, Erik. Thank you for joining us, and thank you, everybody. We'll talk to you soon.